Hi friends, welcome to another video, Unit 1, Day 6. Now we're going to be solving radical equations. Radical equations represent a very interesting type because now we're going to have essentially a way that we need to get rid of a radical symbol. And it's generally because we have a variable underneath the radical that we need to isolate. So the directions are over here. It says get the radical by itself on one side of the equation. Sometimes you just have one radical and it's a little bit easier to do, like this example here. So let's go ahead and add the square root of 15 minus 2x on both sides. So we're going to add the square root of 15 minus 2x on both sides. This is going to give me x equals 15 square root of 15 minus 2x. Now it says raise each side of the equation to the power that is the same as the index of the radical. So if you have a cube root, then you would raise it cubed. If you have a square root, you raise it to the square. You square it, raise it to the square. If you have a fourth root, then you raise the fourth power, so on. So for this one, because it's a square root, we're going to square both sides. So if I square both sides, then what we do is we end up with x squared equaling 15 minus 2x. Now we need to get everything to one side. If you notice that step 3, if the equation still has a radical, then we repeat steps 1 and 2 until all the radicals are removed. We no longer have a radical with this one. So what we can do is we can go ahead and just get everything to one side and then solve. I'm going to go ahead and add 2x on both sides and subtract 15 on both sides. So essentially moving everything over to the left-hand side. So I have x squared plus 2x minus 15 equaling 0. So now we just need to factor this and then solve. So I have x looks to be like x plus 5 and x minus 3. Set each of these equal to 0 and then solve. So we've got x plus 5 equaling 0, x minus 3 equaling 0. Subtract 5 on both sides, x equals negative 5. Add 3 on both sides, x equals 3, and then we're good. Nope! Be careful. So now, we are in square roots, we are in radicals, we need to make sure that we are inside the domain. So first, to find out what the possible domain is, I'm going to grab a different color. Let's use purple. In this case, so I'm going to actually take what's underneath the radical, set it greater than or equal to 0, and then solve. We did this previously, so just as a refresher. So we have 15 minus 2x is greater than or equal to 0. So this gives me my possible domain. This is my domain. So I'm going to subtract 15 on both sides. So I have negative 2x. It's greater than or equal to negative 15. Divide by negative 2. And you get x is less than or equal to. So x has to be less than or equal to. Looks to be like 15 over 2 as a decimal at 7.5. Which is good to know as we go through and check our answers. So, do both of these work? Are both of these solutions inside the domain? The answer is yes, they are. So both of them will work just fine. And we are good with this problem. So that means both of these solutions work, and we are good to go. Number 12. This one's a little bit dicier because we have two radicals. Again, approaching this problem, we want to make sure that we're raising, whenever we square things, we like to square positive values if possible. Looking at this, if I wanted to just isolate, so I just had one single radical on this side, I'm going to actually isolate and move over the negative, the minus square root of x plus 1. So I'm going to add the square root of x plus 1 on both sides. If you think about how this is going to end up, we will then have a positive then on this side that we can work with, as opposed to it being a negative. So on the left-hand side, we have 2x plus 3 is equal to 1 plus the square root of x plus 1. All right, next step. Now we need to square both sides. The reason is because we're taking the square root. Squaring undoes square rooting. So if I square both sides. So square. All right, this is where things get a little bit dicey. When you square this side, everything's good. A lot of students mess up here. Now, when you square this term, you're going to take your first term times your first term. So 1 times 1. Again, that's 1. Your middle terms, you're taking the square root of x plus 1 times 1, and then you're taking another square root of x plus 1 times 1. Keep that in mind. Now your last term here, this x plus 1 square root of x plus 1 squared, those two cancel, and you're up with just plus x plus 1. Let's combine all this together. So 1 plus 1 is 2. I'm just going to bring the 2x plus 3 on the left-hand side. 1 plus 1 is 2, and I have an x, so I have x plus 2 plus, now I have 2 of these. When you combine them together, you're going to add, sorry, I realize this has become quite blurry, and that is really hard to see. There we go. Plus 2 times the square root of x plus 1. So, knowing that I have the 2 times the square root of x plus 1, I'm going to have to keep that in mind as I square both sides and work from this, even farther. Let's go ahead and simplify all this, so I just have the radical over here. So minus x on both sides, minus 2 on both sides, so I end up with just x plus 1 over here equaling 2 times x plus 1. All right. Again, I want to just have the radical. I don't want to have that 2 out in front. That 2 is multiplied, so if I divide by 2 on both sides, I will eliminate the 2 in front. So now I have x plus 1 over 2 is equal to the square root of x plus 1. Now, again, go back and repeat. So we're going to repeat the steps. I need to square both sides. When you square both sides, remember you are squaring the numerator and the denominator over here. So keep that in mind. So we're squaring all of this term here and this as well. So we're going to end up with x squared plus 2x plus 1 over 4 is equal to, and on this side, I have this x plus 1, square root of x plus 1 squared, so I end up with just x plus 1. This looks a little bit tricky because now we're dividing by 4 on this side. Remember, to get rid of it, we just need to multiply by 4 on both sides. So if I do that, if I multiply by 4 here, I multiply by 4 on this side. Remember, if I multiply by 4 on this side, I'm multiplying everything by 4, so we're going to have to distribute that 4. So I end up with x squared plus 2x plus 1 equaling, let's see, that's going to be 4x plus 4. Let's get everything to the left-hand side, so minus 4x and minus 4 on both sides. Minus 4x minus 4, so I end up with x squared minus 2x minus 3 equals 0. So then if I factor this, I have x, looks to be like x minus 3 and x plus 1 equaling 0. Set both of those equal to 0 and then solve. So I'm going to have x minus 3, x minus 3 equals 0, x plus 1 equals 0. Add 3 on both sides, so I get x equals 3. Then minus 1 on both sides, and I get x equals negative 1. Again, I need to know if this is part of the solution set. Now, we have 2 values under the radical here. So because we have 2 possible kind of scenarios for this, we need to take the most restrictive. So for this particular situation, we have the square root of 2x plus 3 and the square root of x plus 1. We need to find which one's going to be more restrictive out of these 2. Which one eliminates more of the possible solutions? Because we don't want it to work for one solution, or one radical, but not the other. If it doesn't work at all for either of them, it doesn't work, period. So I have, in my domain, so my possible domain, I set the square root of 2x plus 3 greater than or equal to 0, and then solve. Minus 3 on both sides. So I have 2x is greater than or equal to negative 3, divide by 2. And I have x is greater than or equal to negative 3 halves. So that's one of the values in my possible domain. Notice that both of these fit, so that's okay. Negative 3 halves is really close to negative 1. Remember, it's above it, so you're okay. Greater than. And then square root of x plus 1 equaling to 0. So again, I have x plus 1 greater than or equal to 0, minus 1, so I need x is greater than or equal to negative 1. Now, be careful, it's greater than or equal to. This is okay. These are both in the solution sets. This one is more restrictive, so this is the one we go off of. When you have a scenario of 2 radicals, you want to make sure you look at the more restrictive one when you decide your answer. Join me in the next video as we continue on with the rest of the notes. Have a great day.